Hello, everyone. In this video, we are going to be covering the notes and examples from section 2.6 on the second derivative and concavity. So let's go ahead and get started. Before looking at the examples on this first page, I want to bring up the concept of a critical point of a graph. There are several situations on a graph in which we might find a point critical. So let's look at some examples to first make sense of what we would mean by a critical point on a graph, and then we'll look at the definition. So I've drawn up here a couple set of axes to help us first start to look at some examples. So one set of particular interesting critical points on a graph is when our graph has a maximum or a minimum. For parabolas, for example, like these graphs, a critical point would be this max or this min. But there are other ways in which our graph could have a max or min. And that could be something like the following. Our graph could have a corner or a cusp. Another type of critical point on our graph is when our graph changes concavity. We're going to be looking more at that in this video. I'll draw a picture for an example. And then another type of critical point is when our graph changes behavior in another way. So let's look at what's happening in each of these types of graphs. So in this first example, we see that our graph increases, then decreases, or decreases, then increases. Whenever we're in that situation, this value, the min or the max, is a point on our graph in which the derivative is 0. So I'll label this point C, this point D. So for these graphs, f prime of C is equal to 0. And say the next graph, I'll label the function G, G prime of D is equal to 0. And in this situation, we have a max or a min. Now, in this next situation, we also have a max or a min, but what's happening with the derivative at these points? It's undefined. We can't make sense of a derivative at a corner. So for these graphs, I'll also call f and g, f prime of c, g prime of d are both undefined. We can also say they do not exist, D and E. In this next situation, our graph changes behavior at this point that I've highlighted. And in what way is the behavior changed? Well, we're going to look at this more detailed in these notes. But one thing we can observe here is that at the start, the change of our rate of change is decreasing. So at first we're really steep, and then we get into a less steep slope. Then our derivative goes from changing a little bit to changing a lot. So we see our slope gets steeper as we move to the right. So there's something critical happening at this in-between point. And what is that critical component happening? Well, our rate of change is changing. And again, we're going to make more sense of that in these notes. But one thing we can observe at this important point is our derivative is again 0. If we look at our tangent line at that point, and that is the line that best approximates our graph at that point, the slope of that line is about 0. And if I was a little bit more careful with my drawing, it would be exactly 0. So we see here that if our graph is labeled the function f, then f prime of c is again 0. But notice that here, as opposed to the first example, we do not have a max or a min. So just because our graph has a derivative of 0 at a point does not mean we have a max or a min. So I'm going to say not a max/min. And so there's another situation where this happens, this type of behavior where our rate of change changes. That looks like a graph like this. What's happening with the derivative at this point that I circled here? Well, here, if we draw our derivative, or our tangent line rather, the slope of that tangent line would be undefined because our tangent line looks like a vertical line. So in this situation, f prime of c does not exist. So these are the situations in which we'd say our graph has a critical point. So I'm going to summarize that here. So a critical point on our graph is defined as the following. So I'll say C is a critical point on a function f of x if f prime of c is equal to 0 or f prime of c is undefined. I'm just going to box that up for us because we will be referring to it later on in these notes.